Yes, student. Next one, thermal stability of hydrides of group 16th element. Student, the general formula of the hydrides of group 15th element is H2E. That is E stand for 16th group element. It will be equal to E if written as O, if written as S, then written as Se, then written as Te, and then written as Po. Then we can write the general formula will convert into compound. Compound like what? H2O, this is H2S, this is H2Se, this is H2Te, and this is H2PO. So in this way we can convert. Now, what is the meaning of thermal stability? The meaning of thermal stability is on heating, the breakdown of H and E bond, that is H2 and E2 is getting converted on heating, like 2H2 plus Et is equal to 2H2 plus E2. So how many temperature required to break down a particular compound into its elemental form? This is called thermal stability. As greater the energy required, more will be the thermal stability. Now the breaking down of bond will depends on the bond length and the bond dissociation enthalpy. In case of water that is what? HO, bond length is very short and therefore the bond dissociation enthalpy will be very high. Therefore what? Breaking down of HO bond require very high energy. That means what? In H2O, the thermal stability will be very high, which will gradually decrease when we move down the group. Student, the thermal stability of water is approx 2200 Kelvin, while in case of H2S it is only what? 673 Kelvin. It is due to larger bond length between H and S. Moving down the group, the H and E, we will call it what? E, will further increase. So the thermal stability will gradually decrease. Student, on the basis of it, again we can explain reducing property, that is tendency to reduce. Okay, except water, all hydrides act as reducing agent. All hydrides act as reducing agent in aqueous solution. Why? Student, water, the bond length is very short. Okay, moreover, in aqueous solution, the H2O forms intermolecular hydrogen bond, and thus the tendency to release H is very weak in case of water. But as we move down the group, the bond length will increase. The tendency to form intermolecular hydrogen bond is getting completely finished, and therefore as greater the bond length, easy to release hydrogen, thus the reducing agent or reducing property increases. So again we can say what? H2S is the weakest reducing agent. Okay, even H compared to H2S, while you can directly write here the H2Te is the best reducing agent. Student, I am writing in short. It is because already these phenomenon are explained in the case of what? Hydrides of 15th group. Okay, the notes are even same. Like here, next one, acidic nature. Acidic nature means what? Acidic nature means H2O, when it dissociates, it gives OH anion plus H cation. But again, it has one more hydrogen, therefore it converts into O2 anion plus H cation. So these types of hydrides are called diprotic hydride. Diprotic means tendency to give two number of H cation, isn't it? But student, experimentally we know that the 1 mole of hydrogen forms only H cation what? 1.0 into 10 to power minus 7. This is its dissociation constant. That is very less amount of hydrogen cation is obtained. Why? It is because in aqueous solution again the H2O forms intermolecular hydrogen bond, and due to formation of intermolecular hydrogen bond, the tendency to release hydrogen cation is very weak. Thus the H2O is the weakest acid even we are calling it what? Neutral, because its pH is what? 7. But as we move down the group, now the H2S, due to larger bond length, it can easily release H cation, thus H2S is more acidic, and if we deal, the most acidic will be what? H2PE. So the related question is also given there, like why H2S is weak acid as compared to the H2PE. So here you can give answer. The bond length between H and PE is large, unable to form intermolecular hydrogen bond, so its acidic strength is even stronger. Okay, student, I am not writing very more. It is because already the content is explained and the notes are given. You can refer, but you have to watch video carefully.